Today I'm going to show you how to use two different types of models to subtract fractions. The first model we're going to use is a linear model, which in this case is going to be our fraction tiles. And the second step I'm going to show you is an area model, and I'm going to be using pattern blocks for our area model. So the first thing we need to do is look at our word problem. Ben has to read 2/3 of his book by Friday. He already has read 3/6. How much does he have left to read? So in this case, 2/3 is how much the total is, and he has already read 3/6. So the problem will be set up as 2/3 subtract 3/6. Now it's important to note a common misconception that students have. This is the part-whole definition. What they may not understand is that the denominator is the number of parts that the whole is being divided into, while the numerator is the number of parts taken into consideration. The denominator does not mean 3 different pieces. It means a whole is divided into 3 pieces. This is why when we have a problem such as 2/3 subtracting 3/6, we have to make the denominator a common unit first because the whole is divided into 2 different size parts. So in our problem, we have 2/3 of our whole, and we're trying to subtract 3/6 of a whole. Once again, we cannot subtract 2/3 from 3/6 without it being a common unit. To find a common unit, we have to find what we can change 1/3 and 1/6 into that shares a common unit, or meaning they have the same number in the denominator. So let's try 1/6. Since this is already 1/6, we know we cannot go lower than 1/6. As you can see, 2 1/6 units fits a 1/3. So we know that 2/6 is the same as 1/3. Since we have 2/3, we're going to need 4/6 in order to equal 2/3. Now, since we have the same common unit, 1/6, we can subtract 4/6 by 3/6. Now our remainder is only 1/6. That was the linear model. Now I'm going to show you how to do the area model using pattern blocks. For this, we're going to use the hexagon as our whole. Since we know that the rhombus, 3 of them make a whole, we have 2/3 shown below. Then we have another whole, and we have 3/6 on this one. I'm using the triangles because we know that 6 triangles will fill up this hole. Once again, we cannot take 3 triangles from 2 rhombuses because they are not the same unit. We'll have to make these rhombuses the same unit as the triangles. With your other patterns, you can see how many triangles it takes to make one rhombus. You can see that it takes 2 triangles to equal 1 rhombus, so we need 4 triangles in order to equal 2 rhombuses. Now what you can do is subtract your 4 1/6 by your 3 1/6 like we did in our linear model. And we are left with 1 triangle. Once again, we know that 1 triangle is a 1/6 of our whole, so we are left with 1/6. When adding fractions, this can be related to whole numbers if the number in the denominator is the same as subtraction. For instance, if we had a problem like 1/3 plus 2/3, and we have the same denominator, we can keep it the bottom denominator as 3. You would add the top like you would add a whole number, so 1 plus 2 equals 3. When subtracting, if the denominator is the same, such as 2/3 subtracting 1/3, Once again, the 3 is the common unit, so you can keep it the same, and then you'll subtract like you would a whole number. So 2 subtract 1 is 1/3. Thank you for listening, and I hope you've learned more about how to use the linear model and the area model to subtract fractions.